the first frame and also in the second frame. Source MAC is MAC 8 and destination MAC is MAC 5. Look at here, we are sending this traffic from the computer 5 to computer 8 from the TX pin of the C5, and we are receiving in same time the traffic in the receive pin of the for example NIC of the C5. Because of that, here we don't have any collision. This is the second condition. And the third condition is that when you are sending traffic from PC5 to PC8 and in the same time from the PC6 to PC8, as I mentioned before, here again we don't have any collision. Look at here, from PC6 to PC8 with the source MAC of MAC 6 to destination MAC of MAC 8, we don't have any collision. Why? Because in each port of a switch we have a buffer. When you are sending a traffic or more than one traffic to this port, the traffic should be buffered in a queue, okay, and after that the traffic can be forwarded one by one to the destination. For example, if the first traffic is received by switch is the traffic of C5, the switch can first forward the C5 traffic to C8 and after that the C6 traffic to the C8. This means that here again we don't have any collision, and now we can better understand now why we don't experience the collision in the when we are using the switch. Because of that, when you use switch, you have the multiple collision domains. Each collision domain is residing in each switch port. For example, this is a collision domain because we don't experience collision between this port and another port, and this is another collision domain, and this is another collision domain, okay, and this is another collision domain. If you have a switch with 4 ports, you have 4 collision domains, okay. And this is so important to know because in many of the exams about the CCNA interviews about the CCNA, you have some answers, some questions about the how many collision domain are exist in these networks. Okay, this is so important for you. After that, let me to emphasize that only when you are using the switch you don't have collision, but when you don't have collision, you don't need the CSMA CD. Because of that, in most cases, in most products of the for example, switch products, when we are using the direct link, the point-to-point links between the computer and switch, the CSMA CD automatically should be turned to off. Okay, why? Because when the possibility of the collision is not available, if we don't need to use the CSMA CD for saving the resources of the devices, we can disable the CSMA CD or we can turn off the CSMA CD. This is automatically occurring. But when you are using hub, the CSMA CD automatically should be changed to on. Why? Because we have the possibility of the collision. When we have possibility of collision, we need to use the CSMA CD. But when we don't have the possibility of collision, okay, we don't need to use the CSMA CD. Let me to give you one example. When you are residing, okay, alone in one room, you don't need to wait or to hear the space for talking, for example, because you are alone. But when you are residing in some people in one room, you need to use the rules. You need to first hear the air. If you don't receive any voice, you can talk. Okay, because of that, we need CSMA CD in one collision domain. But when we are residing in another collision domains, for example, I and you and our friends are residing in different rooms, we don't need to wait for talking of the others. We can start talking every time we want. And this is one of the other advantage of the switch networks. We call these networks, the networks creating with the hub, the shared media or Ethernet shared media, because this media is shared between these systems. For example, C1, C2, C3 and C4, they can't use this for example media in all times. This is a shared media between C1, C2 and C3. But here, as you can see, we have point-to-point links between the computer and also the switch point-to-point links. And look at here, this is a one point-to-point links, this is another point-to-point links, this is another point-to-point links, and this is another point-to-point links. In point-to-point links, we have one collision domain, and we don't need to use the CSMA CD, okay? Another important concept that we can talk about that is the duplex. Duplex means each system can send traffic in, for example, in which time. Let me talk about that. We have three types of the duplex. Let me write here. The first duplex mode is that we have half duplex and also a full duplex, but let me say that we have triple type of duplex. Simplx is the first type, half duplex is the second type, full duplex is the third type. What is the simplex? Simplex duplex means only one system is sending and another system is receiving. Or in one system we have sender, in another system we have receiver. In network we don't use the simplex in most cases. Okay, for example, about the TV, when the TV, satellite is sending the TV waves to your computer, to your TV, your home TV, you are receiving these signals, but you don't send anything to the satellite. This means that we have only the receiver and the satellite is the sender. This means that we are using simplex method. But in half duplex you can send and receive, but this means that we have sender and receiver, but not in one time. For example, in one time we need to send, we can send, and in another time we can receive. In the same time we can send and receive. For example, in walkie-talkie, when you are using walkie-talkie, first you need to wait to finding empty line, empty wave or empty frequency. After that you can talk. You know that, for example, in these networks, when the C1 needs to send traffic, it should wait for empty line. After that, it can send. This means that when we are using the Ethernet shared media or hub, we have the option of half duplex. This means that in one time we can send and receive. But when you are using full duplex, you can send in one time and also receive in the same time, such as the telephone. When you are talking with your home phone, for example, you can talk and also you can hear. You don't need to wait for talking of the other side after that, for example, starting the talk. We can talk and also we can hear, such as this scenario. In this scenario, you know that when the C5 sending traffic to C8, in the same time, the C6 can send traffic to C7 or C8 to C5. This means that here we have the full duplex operation. And in full duplex, we have more efficient way of the sending of the data. Because of that, one of the other benefits of using the switch in the network is that we have this opportunity to using the full duplex communication. Very good. Now we can understand that in full duplex operation, we don't need the CSMA CD. Because of that, the CSMA CD automatically is changed to the off state. But when we are using half duplex, we need to wait to others to sending. After that, we can send. Because of that, we need the CSMA CD. What is the CSMA CD? Let me to review. A device with the frame, for example, C2, to send listens until the Ethernet is not busy. This is the first step. The second step, when the Ethernet is not busy, the sender begins sending the frame. After that, the sender listens while sending to discover whether a collision occurs. Collision might be caused by many reasons, including unfortunate timing. If a collision occurs, all currently sending nodes do the following. First, they send a jamming signal that tells all nodes that a collision happened. They independently choose a random time to wait before trying again to avoid unfortunate timing. And after that, the next attempts start again. This is the CSMA CD. In the modern networks, we don't need the CSMA CD, but let me to say that in some cases, we have again the CSMA CD. This is not a good choice, but maybe in some cases you encounter in some old networks that somebody connected the switch to the hub. For example, connected to the one port of switch to hub, and after that it can connect more than one PC to the hub. They think that this function is a good function. This task is a good task because that it can connect two PC to one port of switch. But here we will experience the collision. This means that if you have to switch only when you are using point-to-point link, you will not have collision. But if you connect the switch to hub and then to other PCs, again the possibility of collision is available, and this is not a good practice. You shouldn't use the hub at all in your networks. Okay, let me to give you one example. Look at these two pictures. First, the left picture, as you can see, when we are using hub, when the first system is sending traffic and in the same time the second system is sending the traffic, we will experience the collision, and this traffic cannot be used. And now look at the right picture. In the right picture, I connected the computer A to switch 1 directly. This is a point-to-point links, and also the computer B to switch 2. This is again the point-to-point links, but I connected the one hub to switch 2 and another system to the hub. Because of that, here we can use full duplex. We can send and receive simultaneously, because here we don't have the possibility of collision. And the CSMA CD is off between the switch A and the computer A. Switch 1 and computer A. Between two switches, we are using again the point-to-point links. Because of that, we don't need to use the CSMA CD, and here we can use the full duplex communication, and also between the switch 2 and B and the switch 2 and computer B. But before the switch 2 and the hub and also the computer, we need to use half duplex, and the CSMA CD now is on here, because assume that here we connected multiple computers. When you are sending a traffic to the hub should flood the traffic to other ports, and if any computer is sending simultaneously the traffic, we will experience the collision. Because of that, here we need to use the half duplex. When you are using half duplex, means the CSMA CD is on. Very good. Until now, we learned about the Ethernet LANs, and this is one of the fundamental topics that we are using it in all of this course. In the next video, I'm going to talk about another important topics about the network, the WAN fundamental, and also IP routing fundamentals. It's a good practice now to reviewing all of the videos about the Ethernet LAN. Now you can gather your information, all of your information in one place after reviewing, and after that you can better understand the fundamental rules of the WANs and IP routing. Don't worry about the configuration. Don't worry about the, for example, commands. You will learn them, and you can easily configure many things in this course. But the important things that now you need to them is the concept. Okay, first you need to understand the concepts. After that, you can easily configure, you can easily maintain, troubleshoot, or verify the configuration. Okay, because of that, now that it's the time of the learning the network. Okay, and we will be ready for learning the configuration of the switch and also routers or some other devices. And now you can better understand why we are talking about the switch only. Why we don't talk about the hub in the configuration, because the hub cannot do anything about the configuration. In hub we don't have any knowledge. Hub only one electrical device. When one traffic, one data, one for example voltage is receiving in one hub port, the hub should repeat it, should replicate it. That's it. But switch can use some of its tables, such as the MAC address table. I will talk about that in the future, to forward the traffic intelligently. And because of that, we have many options about the switch. You will learn about the configuration of switch. In this course, we will configure the switch 1. We can connect to switch 1 with some tools. Then we can use the OS of the switch 1, and we can configure it for more efficiency and more functions of the switch 1. Very good. After reviewing this video and also all of the video about the Ethernet LANs, please come with me to the next video. In the next video, we will talk about the fundamentals of the WAN and also IP routing.